Okay, so the problem is like this. We have some number of containers. There's 6 of them. And 2 participants, okay? So, these are A and B. So the thing about the people is one person, they can talk to each other and come up with some strategy ahead of time. Okay, and one of them sort of knows things and the other one doesn't. Okay, and they can't talk to each other after something happens. So what you have is 6 empty boxes at the start, and then 2 of them get filled up. So it could be any 2. Okay, but only A knows which 2. Okay, but B doesn't know. And so what happens is A shows B one of the empty containers. Okay, and then after which then B picks 4 containers. Okay, and the goal of B is to pick 4 containers, 2 of which contain the things that just got put in. Okay, and so the question could be for more than 6 boxes, but I think it's really easy to nice to consider the 6 case, and maybe when there's 7. Okay, that's what we'll do here. So there's some really good ideas. One of them was if you put sort of, okay, you might want to try this yourself as well, but if you put the 6 containers in a circle, okay, so the good idea was to basically realize that no matter where you put the 2 dots, right, they'll always sort of be within 4 of each other on some arc of the circle. See, like if you put it over here, it'll be even closer. And if you put it on the other side here, it'll be within this arc. Okay? So then what you could do is you could have a strategy ahead of time that the person A will always open the box that's sort of clockwise, if you're going clockwise, in front of the part that has the 4 containers in it with 2 of them full. Right? So if, for example, these 2 are full, okay, so you want the person to open these 4, then you show them this box is empty, and then they'll open the next 4 and they'll get these 2, right? If you want them to open, say, this 4, you'd show them this one, and then they'd go clockwise and open the next 4. Okay, so that's a nice way to solve this problem. So I guess the problem is how to guarantee that B finds those 2 things with 4 picks. Okay. So next, you can have a think about what happens if there are 7 boxes and you still get 4 picks with 2 of them full. Okay, so another way of saying the 6th one was that it's always going to, no matter where you put the 2 things, there's always going to be 2 empties in a row, right? So another way of saying that there's going to be 2 empties in a row, so you can always open the one that's next, or clockwise in front of the one that's also empty, and the other person knows these 2 are empty, so there's only 4 things left to pick. That's another way of saying it. So actually this idea also works for when there are 7 boxes. Okay, so when there are 7 boxes, you can see that if you arrange them in a circle, that 3 of them will always be empty in a row. Okay, so then the other 4 has to contain the 2 full things. So you just have to come up with a scheme that says, like, if I pick this one, that's the 2 next to it are empty. Or if you want to go the other way, it's another way of saying that is the 6 are always, the 4 are always, the things are always within 4 of each other. So you can't get more than 4 apart, and then you can come up with this scheme where you pick the one that's in front of the 4 you want. You reveal the one that's in front of the 4 you want them to pick. Okay, so that's quite cool, and so that's basically sort of the same idea used twice. And then maybe give you a little bit more time to think about what happens if, say, if there are 8 boxes. You know, what happens if there's 8 boxes?